Hey, hello. So here the question is, which one of these four compound is having lowest pKa value? Now, what does pKa mean? First, we have to know that what does pKa mean? What is its relation with acidity? So, the relation between pKa and K is like this. Now, what is K? Ka is acid dissociation constant. Right. So, Ka is acid dissociation constant. That means more the acid is dissociated, more will be its value of K. And since more the value of K, the lesser value will be pK. That means lowest pKa value will be of the compound which is most acidic. Am I right? Yes. So among these four compounds we have to find which one is most acidic. Now okay, we all know that if we want to know whether it's acidic or not, we have to see the stability of the conjugate base. Now what is conjugate base? So let's suppose this is the acid, and if it dissociates, then it leaves a proton, and here we get this anion part. This is called conjugate base, and we represent it like this, conjugate base. So more is the stability of this conjugate base, more will be dissociation, because the equilibrium will be shifted towards right, isn't it? So the stability of the conjugate base increases, the more acidic the compound will be. So for that, we'll see if this hydrogen atom is abstracted, then the carbanion will be formed here. Here this carbanion is resonance stabilized with 3 benzene rings. So it's really good, right? Now if we see at this compound here, it is only resonance stabilized, the carbanion, 1 hydrogen atom will be abstracted. Then this carbanion will be resonance stabilized by 2 phenyl ring, 2 benzene ring. So of course it is apparently very clear, it is very clear that the compound 1 will be more acidic than compound 2, because here is more conjugation. That is confirmed. Now let's move to the third example. This third example, as you can see, where the hydrogen abstraction will go on, here is having this hydrogen because it is having 3 bond. That means another one is hydrogen. So the carbanion will be formed here. Now you can see it is not only resonance stabilized, these 3 phenyl rings are intact, but this is itself is forming another aromatic ring, isn't it? It's a 1 2 3 4 5 6 pi electrons, right? So this ring becomes what? Aromatic, right? And also more conjugation here is happening, not only here but also in this ring, in this another newly formed ring. Now let's move to the fourth example. Now see, here there was only this these 2 are joined, here all 3 are joined. So if this carbanion is formed here, now see, this is one aromatic ring, this is another aromatic ring, and this is another. So all together, not only this phenyl rings are aromatic or conjugated, there is another extended conjugation is happening here, that is with 3 aromatic rings that are newly formed. And also another thing we have to keep in our mind, that for resonance to happen, a good amount of resonance, these rings should be in one plane, so they should be planar. Now see, if 3 rings were, now they are free in a one compound, they are free, but now they are joined by this bond, so they are forced to stay in one plane, they are just forced to stay in one plane. For example, if I just took an example to show you guys, suppose this is the case. Now you are making what? You are also forming a bond here, so this is bound to stay in one plane, not like this, not like this. This is bound to stay in one plane. So more the conjugation, more the resonance, more is the stability of conjugate base. So of course this is the compound which is having lowest pK, right? So this is a question that came in JEE. So I hope I have been able to clear your concept a little bit more. If you think it has done a, a really good job for you, please let me know in the comment section. I'll be really happy to hear that. Thank you. Bye bye. Take care.